Hello, good day viewers. Welcome back once again. Please kindly subscribe to my channel. Also like, comment and share. Today I'm going to show you guys how to solve an initial value problem using the Laplace transform. Here we have y prime prime plus 2y prime plus y. This is equal to 1. We are given the following initial value. The y of 0 is equal to 0 and y prime of 0 is equal to 1. Right? Now let's bring down this equation right over here. We have here y prime prime plus 2y prime plus y. This is equal to 1. Now let's take the Laplace transform of both sides. So here we have the Laplace transform of y prime prime plus 2y prime plus y. This is equal to the Laplace transform of 1, right? Now, with the linearity of the Laplace transform, we can write this as the Laplace transform of y prime prime, then here, plus, because this 2 is a constant, so we can pull it out. So we have here 2 multiplied by the Laplace transform of y prime, then here, plus the Laplace transform of y. This is equal to the Laplace transform of 1. Now the problem here is how to find the Laplace transform of a derivative, right? Now let us start with the Laplace transform of y prime prime prime. So here we have to take note of the following. The Laplace transform of y prime prime prime, this is equal to s cubed, because the order of the derivative here is 3, right? Then multiply by the Laplace transform of y. Now minus s, here we have the power to reduce to 2. Then multiply by y of 0, right? And here, minus s, the power of s will reduce by 1 again. We just have s, and here we have y prime of 0. Then minus, here the power of s will reduce by 1. We have s to the power of 0, which is 1. Then multiply by y prime prime of 0. So we can see what is going on here. The power of s is reducing while the order of the derivative is increasing, right? We have here s cubed reduced to s squared, reduced to s, and reduced to 1. While the order of the derivative from y of 0 to y prime of 0, then to y prime prime of 0, right? Okay, now let's go to the Laplace transform of y prime prime. So here we have the Laplace transform of y prime prime. You know what is going to happen? Here we have s squared because the order of derivative is 2, right? Then multiply by the Laplace transform of y. Then here minus the power of s reduced by 1. We have s, then times y of 0. And here minus the power of s reduced by 1 once again. And we have just y prime of 0. We always stop when s vanishes, right? Then what about the Laplace transform when the order of derivative is 1? So here we have s, just s, because the order of derivative is 1. Then multiply by the Laplace transform of y. Then minus the power of s will reduce by 1, and we have just s to the power of 0, which is 1. Then multiply by y of 0, right? Okay, now with these following properties here, the Laplace transform of y prime prime from here, we are going to replace it with this, right? So from there we have s squared multiplied by the Laplace transform of y minus s y of 0 minus y prime of 0. Then here plus 2 multiplied by the Laplace transform of just y prime. that gives us s. So we are multiplying by 2. So we have here s multiplied by the Laplace transform of y minus y of 0. And here we have plus the Laplace transform of y. So plus the Laplace transform of y, then this is equal to, from the right, the Laplace transform of 1 is just 1 over s, right? Okay. Now we have here s squared multiplied by the Laplace transform of y minus, here we are given an initial value, right? That y of 0 is equal to 0, y prime of 0 is equal to 1. So here y of 0 is equal to 0, so s times 0 is 0. And here y prime of 0 is 1, so we have minus 1 from here. Then plus 2 times s multiplied by the Laplace transform of y, and here minus 2 times y of 0, and y of 0 is equal to 0, right? That will give us 0. Then here we have plus 2 multiply, right? Oh, sorry, plus the Laplace transform, of y. Then this is equal to 1 all over s. Okay, from here, we are going to add 1 to both sides of this equation, right? Here we have a negative 1. So if we add 1, that will vanish, and right hand side we will have 1 over s plus 1. So here we have s squared multiplied by the Laplace transform of y. Then here plus 2s multiplied by the Laplace transform of y. Then here plus, here we have the Laplace transform of y. This is equal to 1 all over s plus 1. Now, from the left hand side, we have a common factor here, which is the Laplace transform of y. So we factor it out as follows. Here we have the Laplace transform of y, then into brackets, here we have s squared plus here 2s plus here 1, and this is equal to, the whole of this simplifies to s plus 1 over s, right? So now from here, we are going to divide both sides by s squared plus 2s plus 1. Since we are trying to make the Laplace transform of y the subject, right? So here we have the Laplace transform of y. This is equal to s plus 1 over s, all divided by s squared plus 2s plus 1. But we're very lucky from here. You know, s squared plus 2s plus 1 can be factorized, right? So here we have s plus 1, you know, this denominator here, the two of them will multiply together, and here we have all over s into bracket s squared plus 2s plus 1, right? From here we have s plus 1 all over s into brackets, you know, this is a perfect square, right? So that is s plus 1 squared. So from here we have the Laplace transform of y. This is equal to, you know, from here we can rewrite that as s plus 1 all over s into bracket s plus 1 times s plus 1, since this is squared. So from here we cancel out this, then we have this is equal to 1 all over s into bracket s plus 1. Now the numerator we can rewrite it as that is s plus 1 minus s, right? Then all over s open bracket s plus 1. Okay, then from there we can split the denominator. So here we have the Laplace transform of y. This is equal to, we have s plus 1 all over s into bracket s plus 1, right? Then minus s all over s into bracket s plus 1. And from here, this cancel this, we have just 1 all over s minus, this s will cancel this s, then we have 1 over s plus 1. So from here we can see now we have the Laplace transform of y. This is equal to 1 over s minus 1 over s plus 1. So from here we are going to take the inverse Laplace transform. We all know that the inverse Laplace transform of a function, the inverse Laplace transform of the Laplace transform of a function is the function itself, right? So here, if you take the Laplace transform of the Laplace transform of y here, we have just y. And this is equal to the inverse Laplace transform of 1 over s minus the inverse Laplace transform of 1 over s plus 1. Right? Okay, now let us recall the following properties of inverse Laplace transform. We have that the inverse Laplace transform of 1 over s plus a, this is equal to e raised power of negative a t, and the inverse Laplace transform of that is k all over s, this is equal to the k, the constant, right? So from here we get y is equal to the inverse Laplace transform of 1 over s. 1 here is the constant, so that will give us just 1. Then minus here, we are going to let a equals 1 here. If you let a equals 1, from here you get the inverse Laplace transform of this, which is e to the power of negative 1 times t, which is negative t. And this is the solution. Thank you for watching. Please kindly subscribe to my channel. Also like, comment, and share. Bye-bye.